the, let's say, the impact of AI and machine learning in all aspects of our lives, starting from those smart watches and ending with, like, for instance, smart homes, smart cinemas, and so on. And there are plenty of applications of machine learning nowadays. I'm going to just list a few here in this slide. So for instance, now we can build advanced machine learning algorithm that could detect the skin cancers, and the accuracy of those models is better than a certified dermatologist. Okay. Now AI is widely used in self-driving cars, you know, Tesla, and all the movement that Tesla can, and the decision that Tesla could do, okay, powered by deep learning algorithms, okay, object detections, okay, and stuff like that. All this could happen using these deep learning and AI. And if you are a gamers, and if you a fan of, let's say, video games, now AI is used to create powerful, let's say, smart agents that were able even to defeat world champions in AlphaGo and AlphaStar. You know, those strategic games. You know, Deep Mind. This is very popular company in London. Okay, they are really doing amazing works, and one of the work that done is the AlphaGo and AlphaStar. They have designed a smart AI system using something called reinforcement learning. Okay, and they have used this type of learning to create powerful AI agents to play against world champions and beat the world champions. Okay, and if we would like to talk about other applications, okay, in industry, in let's say transportations, okay, we will still talking for hours. Okay, now let's have a look at what's different in machine learning. I guess all of you have done programming somehow, okay, in your background. If you don't, that's totally fine. But let's try to compare between the traditional programming and the machine learning. So in traditional, and let's take an example first. So let's assume I want to design a program, okay, using C# or maybe Python or any other language you prefer, to predict the weather forecast for tomorrow. Okay, I would like to predict the weather forecast for tomorrow. So what do you think? What I supposed to do in such a situation? Any help? So if I want to design a program, predict the weather forecast for tomorrow. So what do you think? So I should start first by, let's say, understanding the problem, and then maybe writing some functions to, let's say, solve the problem. So this means that I have to write, let's say, a function that inside this function, if the wind is, for instance, wind speed is this number, and if it is sunny, if humidity is low, then I will play tennis, right? So I have to provide the rules. Those are my instructions that I want to provide. And also I have to provide the data that I need to work on to decide. Then the machine is going to, or my program is going to tell me, okay, should I play tennis or not? Now, let's try to make it a bit complicated. Let's assume I want to design a program to distinguish between cats versus dogs images. So can you now write a program for me that distinguishes between cats and dogs images using the traditional programming? What do you think? So I guess solving such kind of problems using the traditional programming is going to be very hard. Now, on the other hand, let's think how we can solve this using machine learning. Now, in machine learning, we are providing the answers and the data for our models or the machine, and the machine is going to discover the rules. Okay, so what does it mean? It's mean that, let's talk about the cats and dogs example. So what I'm going to feed the model in this specific example, I'm going to provide the photos. The photos are the data in this case, okay? And also I'm going to provide the answers. What the answers mean? It's mean image label. Okay, I know that this is a cat image. I know that this is a dog image. So I already know that this image is a cat. Okay, so this is the answer. Because again, remember one step back. So what is the aim of my system? I want to distinguish between cats and dogs. So I want, for instance, my output to be, this is like 80% chance to be a cat. So I want to see, to predict the answer is going to be a cat or a dog, right? So I'm providing here also answers. Now, what's machine learning do? It try to find a pattern between the input and the output. Okay, think about this like a magic black box. You feed it with something, it gives you the rules. Try to map between inputs and outputs using math functions. Okay, so it's trying to find that patterns between input and output, and this pattern could be applied when I want to test this system on new instances that had never seen before. Okay, so this is the main difference between the traditional programming and the machine learning. Now here I want you to take a look, think about this, to understand more the aim of machine learning. I have this input. I guess we had all played this game somehow in your childhood, right? So we have this input and this is my output. I want you to find or discover the relation between the input and the output. Can you like try to have a minute or so, try to understand how we can, let's say, find out the output. Oops. How we can find the output. Okay. So what do you think? Any thoughts, any ideas? So if we try to decode it, well, this is going to be the formula of converting from Celsius to Fahrenheit. And I believe this is going to be hard to guess, right? And this is what exactly machine learning does. I provide input, I provide output, and then my models and my machine learning model is going to sort out, going to figure this relationship, this formula. Each time I'm going to provide now a new input. Let's say it's 40 degrees Celsius. So then my model is going to apply this formula to find out the Fahrenheit. And this is exactly what machine learning does. It's trying to find out the rules. Okay, so I hope now it's clear. Now let's move to talk about the different types of learning that we have. Now it turns out that we have three different types of learning in machine learning. So we can mainly divide them into three categories. The first one is called supervised learning. Second one is unsupervised learning, and third one is reinforcement learning. And we have different types of application for each of those learnings, okay, types. Now, let's start with the supervised learning. Supervised learning means that I must know the labels of my samples. It's mean that, do you remember the example of cats and dogs? I said I want to, let's say, design a system to distinguish between cats versus dogs. So what's the input in my case? It's going to be a set of images. Maybe I have 10K images, 20K images, 30K images, whatever. And also I have to provide the answer of for those images. It means that each image must have a label, okay? And this label means it could be either a cat or a dog. Okay, so that's why it's called supervised learning, because the learning, okay, it's the learning technique, the learning process, it's being guided by the labels, okay? And we use this sort of learning in predictions in general, okay? So we can, when we need to predict the future, we rely on supervised learning techniques. And we have different algorithms that fits under the supervised learning umbrella, okay? In our course, we are going to not spot the light. We are going to talk in depth in different algorithms, okay? And we are going to see how the algorithms work, and you will have the chance also to do some kind of calculations. The second type of learning is the unsupervised learning. So here, and you know, sometimes we consider the unsupervised learning as an extension for the EDA. You know what's the EDA? I guess you have been doing this in the morning. So it's the exploratory data analysis. And we can consider the unsupervised learning under the EDA because we use it to discover some hidden characteristics between the inputs. So in supervised learning, I aim to learn some special sort of hidden, let's say, features of my inputs, and hopefully I can group them together by clustering, or maybe I can use it in dimensionality reductions. So I have complex features I use unsupervised learning, let's say, to simplify my space or my vector space. Okay, so this is kind of unsupervised learning. Now for the reinforcement learning, this is like mainly wide in, let's say, expert system, or let's say smart systems. And in reinforcement learning, the machine is going to learn via interactions. And if, for instance, let's talk about robotics, because mainly reinforcement learning using robotics and self-driving cars. Now let's talk about robotics. So if I have some kind of dog robot, and it's working, so if the robot is going to hit a wall, then I'm going to apply some sort of, let's say, penalty functions. Okay, and if the dog is walking correctly using the path that I have asked the robot to follow, then I'm going to reward this by applying also some kind of math functions. So in reinforcement learning, the learning is done by penalties and rewards. Okay, so those are the main three types of the machine learnings that we have. Now let's spot the light on the supervised learning first. Okay, but before moving into that, let's have this quiz together. So I'm going to ask you different questions, and then you are going to tell me what is the learning type that I should follow. Okay, so spam email detection. So what kind of learning I could follow or I could use to solve this problem? What do you think?
The first thing is use unsupervised learning.
Exactly. Very good. So we use supervised learning, but why supervised learning? Because at the end, I have two categories, right? I have spam and non-spam emails, right? And I aim to do some sort to develop a model that helped me in this, let's say, detection. So, and this is exactly what your Gmail or maybe Outlook does when it comes to filtering spams than spam. Okay, so it's used supervised learning to detect those emails. Now, what about face recognition? What do you think about face recognition? Is it like unsupervised learning, supervised learning, or maybe reinforcement learning? What do you think? So let's have a look together at this. So I should have like photos, and each photo should assign a name, right? So otherwise, I won't be able to detect faces. So this mark faces is this my faces, and this your faces. Okay, what's this? This your face, my face, Mark's face, whose face is this? So in such a scenario, guys, we should have an images of different faces, and each face should assign a name. Okay, and this is kind of, it's like something similar to the cats versus dog example. Okay, I should have a photos, each photo should have a label. Now, what about the third one? Customer identification for a marketing campaign. What do you think? So this is kind of unsupervised learning. Okay, I use the clustering to try to find out some common characteristics between my customers. So this helped me to understand better the customers and launch a specific marketing campaign for those. Okay, now let's have let's say now move to talk about the regression. Now I've said but what is regression first, and what is a classification? We said we use supervised learning for what? To make predictions, right? Now in predictions, I can then split the prediction into two different types. If I'm going to predict numbers, which mean, for example, I want to predict the stock price for something. So it's a number. I want to predict the house price. This is another number. So I call this problem a regression. I guess yesterday you had been introduced to the regression, right? And if I'm going to predict some categories, okay, I use classification. For instance, I want to predict spam, non-spam. I want to predict, for instance, dogs breeds. You know, we have different dogs breeds like Husky, German Shepherd, etc. So this is sort of classification problem. And as I mentioned earlier, supervised means that I must have the labels, okay? So I can develop a model and then I can use the model to do predictions on some new data samples. Now, let's have now a closer look at the regression, linear regression. So first of all, what is a linear relationship? What is a linear relationship? What do you think? So in statistics or in stats, the linear relationship is a relationship between two variables, and this relation could be represented as a straight line. So it could be straight line like this. Okay, it should be straight line. It's not straight line. Okay, it should be straight line. Now, if we have such a relation between two variables, then we call this a linear relation. So linear regression is used taking into consideration or into as a assumptions as assumption that I am assuming that I already have linear relationship between my variables. Otherwise, the problem won't be solved using linear regression. Okay, so this is my assumptions here. So you have always to remember this. When using linear regression, you have to make sure that you have linear relation between two variables. Now let's take an example. Let's assume I want to predict the price of a house based on the size of it. For instance, the number of rooms. Okay, so my input variables is the number of rooms. Okay, my output variables or the variable that I want to predict is the price. Okay, now let's try to solve this problem using linear regression. So what's going to happen here? So let's take a few examples first. Let's assume I have one bed house, okay, one bedroom house, and this is going to be 70K. Then I have three bedrooms house, and this is going to be like 100K something. And let's assume I have like 5 or 6 rooms, and the price is going to be 160. Now, if you try to plot those values and try to connect those together, you are going to have a line like this. Okay. Now, I can use this line here to predict any new house. Okay, what does it mean? Let's assume that I need to predict the, let's say, the price of a house, and this house has like 4 bedrooms. Okay, now what's going to happen here? I'm going to use this line here formulas to do the predictions. So to do this prediction, I need to get first this formula, right? I need to get the formula of this line. So if you remember in math, the formula of this line is going to be like this. Y equals B0 plus B1x. And we call this the slope. And this is the intercept. B0 is the intercept, right? And when slope is 0, what's going to happen? It's going to be like horizontal line, the formula of horizontal line. Anyway, so this is the formula that I am looking for. So when I'm going to do prediction, guys, the machine learning is going to try to guess the values of B0 and B1. Okay, it's trying to find the best guess. for those two values, and then I can use those two values to predict any new samples, okay, to make any new predictions. And this is what we are going to do in the exercise today, okay? So this is the idea of the linear regression. Just to summarize, I'm assuming in linear regression that I have linear relation between my variables, which means that the relation between those two variables could be represented as a line, okay? And the machine learning models try then to find out the best of values for those coefficients. Okay, so I can use this formula here to predict the price or anything else. Okay, but again, I have only now talking about two variables. Now, let's take an example here. So if, for instance, B0 is equal to 3.6, B1 is 0, then I'm going to have horizontal line like this. Now, each time you want to develop a model, you have to think about the evaluation of this model. And in machine learning, okay, we have different matrices to evaluate the models. Now, for regression, we have something called mean square error or mean absolute errors, okay? So let's now, let's see, let me introduce you to how we can calculate these errors in a simple linear regression, okay? Now, guys, let's assume that I have this prediction here. Okay, I have this line formula here. Okay, and those were the points. Those are, let's say, the number of rooms. And this is the formula for the linear regression. So as you can see, the line here, okay, we have some, let's say, residuals between the actual data point and my line. Okay. Sorry, just a minute. Sorry about that. So we were talking about residuals. So again, let's assume that I have a data point here, okay, and this is my formula, my line, okay. As you can see, the line in optimal case should be very, very close to the point. However, sometimes I may have those, let's say, residual, and those represent the errors in my prediction, okay. So to calculate those errors, I can use something called a square error. Okay, so what's simply I'm going to find out this distance here between the point and the line. Okay, and I'm going to square them together. So why it's squared? It's just only to eliminate any negative signs. Okay, so now we have different fits, right? So I can fit the point using this horizontal, or maybe with a bit of slope, or maybe this or that, or even like vertical. So what is the best fit? Okay, the best fit is the line that could, okay, lead to a minimum errors. Okay, now let's try. I'm going to read this for you. It's like interactive linear regression, so you can have a set of points and you can try to find the best fit for those. Okay. Now let's talk about now multiple linear regression. Sometimes, guys, I may use to let's say rely on linear regression to solve complex problems, just not only two variables. So in simple linear regression, I can only have as I mentioned earlier, relation between two variables. What if I want to consider other factors to predicting my house price? Let's say now this. I want to rely on the number of rooms, okay, the floor area, and the postcode for predicting my house price. And I guess taking into consideration different factors is going to lead you to a better results, right? So in such a case, we are not relying on linear regression, simple linear regression, but we call it now multiple linear regression, okay? And this is going to be the formula. So instead of having one input, I have now multiple inputs, x1, x2, and xn, okay? Those are the slopes, and this is the intercept, okay? Now let's take an example. Let's assume that I want to predict the length of the mouse body length using its weight and tail length. So my output variable, I want to predict the body length. So it's going to be the y here. And the input, I want to predict the body length using the weight and the tail length. So it's x1 and x2. Okay, so I have two inputs and one output. So the formula in such a case is going to be like this. Okay, I have only two features to consider to predict the body length. Now, if we try to plot a point here, we are going to notice that we are not talking about two-dimensional space anymore. It's now three-dimensional space. Okay, I have here weight and tail. This is the mouse weight. This is the tail length. And also I have, this is y, my y, the body length. So as you can see now, if you'd like to plot a point here, going to be in three-dimensional spaces. Now, if we try to plot different points, going to be something like this. Now, what do you think? How we are going to find the best, let's say, line to in this formula? Okay, how we are going to find the best line, or let's say, I don't know if it's a line. Okay, how we can find this line, or maybe anything else to split those points to find the best fit for those points. Well, it turns out I can't now rely on lines. I have to use hyperplanes because I am in multi-dimensional space, not two-dimensional space anymore, okay? So in multiple linear regression, you try to find out the formula of this, the best hyperplane, okay? That could, let's say, split the points. Now, those are the matrices that I can rely on to evaluate my regression models. Okay, so the most, let's say, popular one is the MSE, mean square error. So what I'm going to do in MSE, I'm going to, as I mentioned here earlier, so I'm going to calculate those residuals. So I found out the difference between this point and the line. I'm going to sum them up all together using this formula. Okay. So this is the mean square error. And we have also another matrices, but it's going to be the same. Now let's now move to the classification. Again, classification is sort. Before I move to classification, any questions? Yes, it is absolutely necessary to calculate the errors. Otherwise, how you are going to evaluate your model? So how you are going to judge if your model is doing good or bad? You need to ask this question all the time, okay? Am I producing a good model, reliable model that I can use in, for instance, to solve business problems or in real life, let's say business scenarios? Can I rely on the model? You need to come up with, let's say, scientific measures, okay, to evaluate the models. And for each type of learning, we have those measures, okay? Otherwise, if you don't have measures, okay, we are not going to have the confidence to use the model in the first place. So it's a must to evaluate the models, okay? Any other questions? Yes, Alexander, I'm a bit fast, but I can slow down, okay? Again, because of the time constraints, but I will slow down. Any other questions? Any other thoughts, guys? Okay. Now let's move to the classification. Again, remember, classification is a kind of supervised learning, okay? And I can use this classification, okay, to on categorical data. Remember, in regression, I can use numbers. In classification, I can use categorical classes, okay? So, and in classification, I aim to find out the best decision boundaries that could, let's say, split my data points correctly. So let's here assume that I have two kinds of points. I have those X and O's, okay? And I aim to develop a model that help me to, let's say, distinguish between X and O's, or maybe predict X and O. So if you try this, and this is called a binary classification. Why it's binary? Because I have only two classes. I have only X's and O's, okay? If I'm going to have multiple classes, like this case here, okay, we call it multiple class classification. So I have here three kinds of points that I want to, let's say, classify or maybe draw the decision boundaries to find homogeneous splits, okay? So this is kind of a multi-class classification. Can you give me an example for multi-class classification? Alexander, I'm going to answer your question, but just let me hear some thoughts here. Can you give me an example about let's say, multi-class classification?
If we have to predict something by using the three different parameters,
Like,
like if we have to predict if it is a dog or not, we have to use three parameters like his body structure, his voice, and his behavior
okay,
or
uh, okay,
sense.
Prachi, this is interesting question, okay? But now, what's you said, okay? We said, you have said that I want to predict a dog or not, using different, let's say, features like the length of the tail, the mass of the body, okay, something like this. But what you are trying to predict? Can you say it again?
If it is the like we
Oh,
have different kind of breeds in dogs, so by the hair or the tail or the
no,
structure
no,
of that
forget.
dog.
Okay, let's forget about the feature. What's the input now? But let's focus on the output. You said you want the first time. You said you want to predict a dog or not. Correct?
Yes.
So dog or no. So yes for dog, and no for, let's say, no dog. Right? So
Mm-hmm.
how many classes do we have here?
Two.
Two. So it's binary classification, right? So you need to focus on the output, what you are going to predict. Now, for your example, now let's change it. Let's assume that I want to predict different dogs breeds. So in such a case, I need to, so my answer is going to be, for instance, I'm going to have like 10 breeds, 10 different breeds, right?
Yes.
So this is kind of multiple class classification. So when I want to count, okay, I want to count the class labels, I focus on the output because the class label is mainly related to the output. Okay, hope it's clear now. Now, you said, Talk, you want to predict the cat, sorry, the dog's breeds based on different features, maybe the length, the tail, maybe the body mass and stuff like that. So those are kind of input features, okay? And I don't count them when I want to determine if it is a binary classification or multiple classification. Okay,
Yes.
I hope it's clear now.
Perfectly. Thank you.
So, Alexander, you are saying that multi-class is considered as a cluster. It does not count as a cluster because here I aim to do predictions. It's mean that I have some samples and I want to find out, I want to predict, okay, the correct a class label for each one. But in clustering, I aim to find some hidden characteristics between my data points, okay? This is what I'm trying to do in clustering. Now, let's take this example here. Okay, let's assume here I have three different types of points. I have triangles, squares, and I have the X. And let's assume I have a new point. Okay, and now in classification, I aim to predict the new, let's say, label for this new point. So this point should be considered as X or square or triangle. Okay, this is what we do in classification. But in clustering, I aim to find out some hidden characteristics between the point to group the homogeneous Okay, let's say items together without knowing about the class labels. I don't care about the class labels here in clustering. Okay. Now this is the classification. Some simple. Any question before we move to the logistic regression? Any question? Now, the logistic regression is a simple, let's say, classifier that help me to do to do predictions. Okay, it's try to predict, again try to find out the correct label using logistic function. Okay, and it's mainly used in like spam email detections. I can use it to predict whether property can be sold or not. I can also use it in to predict whether a political candidate win or lose. Okay, so I have two classes here. Okay, binary classification. Please note I'm using this for binary classification. Okay. Now, example here, I want to predict if a mouse is obese or not using its own based on the weight. So I have, how many classes do we have in this problem? I have two classes, right? I want to predict if a mouse is obese or not. So it's mean that I have is obese. This is the first class. Is it not? This is the second class. So this could be a 0 and this could be 1. Okay, and this is my weight. Again, this is true, I'm going to give it 1, and this is false, I'm going to give it 0. Now, in logistic regression, I try to fit those points using this S-shaped curve. Okay, this is what logistic regression tries to do. It's try to draw the best, okay, S curve that could fit the points. Okay, so this is what the logistic regression tries to do. And to evaluate the classification matrices, okay, to evaluate the classification, we need to rely, as we mentioned earlier, on some kind of matrices, okay? Now, I don't want you to care too much about this slide here, but I want you to have a minute reading this paragraph. It's just, you know, this fable, it's an Aesop's fable. You know the boy who cried the wolf? Yeah, I want you to read the story. Then I'm going to introduce the confusion matrix and how we are going to evaluate our classification models. Okay, so have a minute just trying to read this short story here. Okay, so here, let's say I'm going to refer to the wolf as a positive class, okay? And I'm going to refer to the no wolf as a negative class. I want you to remember those assumptions, okay? So wolf is positive, no wolf is negative. And let's try to summarize our wolf prediction using 2x2 confusion matrix, okay? So we are going now to see what a confusion matrix is. So let's see. Now, let's focus now on the positive. Do you remember what's the positive? The positive was when we have a wolf. Okay, so I'm going to have two cases in the positive class. The first case is called true positive. The second case is called false positive. Now, remember, we are in the positive thing, so it's mean that the shepherd said wolf. But why this is true positive? Well, because the shepherd said wolf and reality was wolf. It's mean that we already had a wolf and the shepherd said wolf. It's mean, in other words, mean that your prediction was correct. You predicted that there was a wolf and it was really a wolf. And this is why true. True because your guess was right, and positive because I assume that the wolf is a positive class. Okay, now here I have the false positive again. Here I have predicted wolf, but the fact reality was no wolf treatment. Okay, there was no wolf, and that's because my guess was not right. I said it's false. And positive because again I have assumed that it's a wolf. Now moving to the second half of this array, okay? I'm going to talk about negative class, and remember negative was related to what? To no wolf. It means that you have predicted no wolf. In other words, we predicted no wolf. That's why it's a negative. Now false negatives mean my guess was not right. False mean my guess was not right. So I have predicted not wolf, but in reality, the case was there was a wolf. It's false because my guess again was not right. It's negative because I have predicted no wolf. Now true negative means I have predicted no wolf and reality was no wolf. And this is the concept of classification, the confusion matrix. This is how we can evaluate the classification, okay, models. So in short, in simple short, I'm trying to predict something. How we are going to evaluate if this is correct or not? Well, simply, I'm going to count how many correct, let's say, predictions I have made, and then I can find out the accuracy. And could be done using those two green parts. So you see this diagonal here? If I am able to count how many, let's say, instances I was able to predict correctly in true positive and true negative, then I can divide them by the total number of instances and find out the accuracy. So the accuracy is shortly can be defined as TP, this is the true positive and true negative, divided by the total number of instances that we have. Any questions so far? Is it clear what do we mean by true positive and false positive?
When we understand or when we realize that we have to use the confusion matrix to predict the data, like
It's we use it to evaluate our model predictions. Okay, so let's assume we have built a model to predict if we have a wolf or no, right? And then I want to find out if this model is accurate or not accurate. Can I really use it? So we use the confusion matrix, okay, to evaluate the models. Okay. Now, let's take another example. So, guys, what do you think? What is a good classification model? So let's say we have developed different models. Okay, the first model's accuracy was 10%. The second one was 50%. The last one was 90%. So what do you think? What is the best model? Which one is going to be the best model? When accuracy is 10 or 50 or 90?
90.
Exactly. So mean that you are guessing, your guess is correct, right? You are making a good predictions. Now let's look at this example here and see. Let's assume that I want to build a model that could help me in cancer prediction. I want to predict benign and malignant cells. Okay. Now let's assume that I have got this nice confusion matrix. So in true positive, I have 1. So, okay, now here I want you to remember, I'm going to assume that the malignant is a positive class. Benign is negative class. This is my assumption here. Malignant is my positive, benign is the negative. So in the true positive, so if I want to calculate the accuracy here, I'm going to sum those two greens, right? So I'm going to, so it's 1 here plus 90 divided by the total number of instances. So it's going to be 1 plus 90 divided by 1, 91.8. It's going to be 91%. So what do you think? Pretty good?
Yes.
What do you think? It seems pretty good, right?
Yes.
Okay, now let's look at this. Let's have a closer look at the results. So I have 100 tumor examples, correct? I have two classes, malignant and benign, correct? Now, I was able to predict correctly only one instance of the malignant out of 9, correct? So look here at the positive here. I was able to predict one only out of 8, right? Now here in the benign, I was able to predict 90 out of 91, correct? Are you with me now? Any question? So those are my results now. Now, what do you think about the results? It seems that my model is doing very well when I'm predicting the benign. However, if I looked at the malignant, it seemed that I only was able to predict one correctly out of 9. So my model seems to predict benign all the time. So if I brought any other models that only trained on benign, I will probably get another 90% accuracy. Correct? So it seemed that here I have an issue with the malignant class. Okay, it seems that I don't have enough labels here for my model to be trained on the malignant. However, on the other hand, I have a lot of cases for the benign, and my model is able to predict all of them. So, do you think here accuracy is still valid when I want to evaluate such model?
No.
No, it's biased. Why it's biased? Because I don't have enough samples for the malignant class. So this is what I was trying to say here. And guys, this is very popular problem in machine learning, especially when we talk about health domain, okay? When you want to deal with health problem in machine learning, most of the samples that are going to come from healthy people. And you have only a few samples related to the people who had diagnosed by this, by, for instance, cancer or maybe COVID-19 or any other disease. And we have some techniques to let's say, to tackle this challenge. Okay, we can talk about this later. But again, I aim to introduce this specific example just to tell you that it's not only about the accuracy. Okay, as you can see, we are achieving 91% accuracy, but still this model is not good.
So
And
that
we
means,
use, yeah, go
sorry.
ahead.
So that means, the model should be accurate for the both the labels, right?
Yes,
Not for
I
the
should.
only one.
Yeah, and I can consider on other classification matrices, we call them precision and recall. Okay. Now we can talk about this in our class, okay, in more details. But for now, just going to maybe leave it for you if you would like to Google it. Maybe try to search for precision and recall. Okay. So we can rely on those two matrices to evaluate the model when we have a doubt, okay, accuracy. Now, finally, I would like to move to unsupervised learning if we don't have any question. Okay, so again, in unsupervised learning, I'm going to deal with unlabeled data, which means that I don't care about labels now. I don't care that they are existing anymore. And I aim to find out, let's say, some homogeneous groups inside my samples, okay? And this is what the clustering is. Now, let's assume here I have different clients, okay? And I want to launch a marketing campaign for VIP customers only. Or maybe I would like to launch marketing campaigns for youth people. So I would like maybe to split my, let's say, customers into different age groups. Or maybe again, VIP, or let's say normal customers. So clustering helps me to find out the common characteristics between the customers, okay? And hopefully I end up with some sort of homogeneous subgroups. And this is the aim again of the clustering. So let's look at this guy here. He would like to maybe increase the profit by identifying the correct customers. By applying clustering, he was able to split those into different categories or maybe different groups. Okay, and then he could launch marketing campaigns for each specific groups. Now, the idea in clustering is very simple. We try to find out the similar points. Okay, so how to find out the similar points? So I see that I need to rely on some similarity measurements. In machine learning in general, we always rely on math equations. Okay, so here I should search for some similarity measures between my, let's say, data points. And I have different similarities or maybe distance if we talk about two-dimensional spaces. So in two-dimensional spaces, the similarity or distance measures, I guess you know those already. I have the Euclidean distance, the cosine, correlation coefficient, and many others. And the Euclidean distance is the most popular one. So in these two-dimensional spaces, if I am able to calculate the distances between the points, then I'll be able maybe to group them based on the distances, right? So this is what we do in clustering. And this is the formula of the Euclidean distance. I guess you have seen this at primary school. So to calculate the distance between 2 points, I have two coordinates here, x1, y1, x2, y2. So the Euclidean distance is it's x1 minus x2, and then y1 minus y2, okay? And then to the power, okay? Same of this. So this is how we can calculate the distance. Now, one of the most popular clustering algorithm is called k-means. So k-means, okay, requires that you provide the number of required clusters. So before the algorithm is run, the algorithm is expecting from you the input, 2 clusters, 3 clusters, 4 clusters, etc. Okay, so you have to provide the number of clusters, and we call it k. Okay. Now each cluster is going to be assigned a center, or we call it centroid. So each cluster should have a centroid, and then what's the idea here in k-means? We said we need 3 clusters, right? So we start with the 3 random centers. And then we start to calculate the distances between the centers and all points. Based on the centers, based on the distance, I'm going to judge the point, the cluster that's related to each point. And then I would update the cluster centers based on the new instances. Then I would calculate the distances again, then finding new clusters, and we keep doing this until we notice no changes on the center. Okay. Now this is what happening. This is what I just explained. I don't want to go through the slide. Let me show you this. Okay. I want to show you this. Up in the name. So let me know when you can see my screen. Okay. Can you see this now? Can you see my screen? Okay, perfect. So now let's try to, here I have like interactive, let's say, tool to show me how k-means works. So it's first asking me how I would like to initialize my centroid. Okay, I'm going to say choose random centroids. Okay, and then what is the kind of data that you would like to test? I'm going just to use uniform points for now for simplicity. So this is like random point, and let's try to find cluster them together using k-means. So first of all, I'm going to add the centroids. So let's say I want 3 centroids. K-means start by assigning random centroids. And let's go to see how it works. So first of all, we are going to calculate the distance between all the new centers and all points. So we calculate the distance from green center to this point, from green center to this point, from green center to all other points. Based on the distance, I'm going to assign the point to the relevant cluster. Okay, so as you can see, the distance from this red center to this point, it's smaller than the distance from this point, from blue cluster to this point. That's why it's assigned to the red cluster. Okay, now after that, as you can see, I have formed 3 groups, but the centroids need to be adjusted because they are not in the center anymore. So I'm going to update the centroid by calculating the average distance between this centroid and all other points. I have updated the centers now. What needs to be next is to calculate again the distances between all new centers and all other points. As you can see here, when I have changed the centers, I still have, you see here the points, those were red. Now they will become green. Those were blue and now they will become green. Look now. You see? Because now the distance between the green and the green center and this point is less than the distance between this point and the blue center. Okay. Now we again update the centroids. We again do the calculation and so on. And we stop when we can find that changes. You see here, it seems that it's not changing too much. So we keep until, for instance, we reach this time. So this is how k-means works. Any questions on k-means? Do you have any questions on k-means, guys? No? Okay, then. Now, finally, I would like to talk about the tools that we can use to apply machine learning, okay? So we have different, let's say, set of tools that we can use to develop machine learning models. So the most popular ones are like using those popular data science library like scikit-learn using Python, okay? And also we have another library for visualization called Seaborn. Now, for the programming itself, the programming environment, I guess you are familiar with maybe some IDEs, like maybe Python or maybe VS Code. But in our classes, we are going to rely on Colab. So Colab is something like Jupyter notebooks, but you can use them free from Google, and this service provided by Google. So it's just if you use just Google Colab, okay, you will get it in the first okay line. And again, this is like interactive notebooks, and they allow you to use GPUs for free as well. Okay, so if you are doing some incentive, let's say deep learning models, and you require some powerful computational resources, then you can use Colab for free, okay? And during our course, again, we are going to rely on Colab, and we are going to use different libraries. So we can use matplotlib for plotting and data visualization. We use pandas for data pre-processing. We use NumPy for some automatic calculations. If you would have vectors, you'll see now in my example, okay? So those are scikit-learn. This is really essential part of our journey during the course. We are going to use it to develop all the machine learning models. Okay. Any questions so far before moving to the lab? Okay. Now let's move to the lab. I guess you have now this link, right? I believe that you have this link here. Now, we are going to work on a data set called Iris dataset, and this is very popular data set in machine learning. We are going to use it, okay, to apply linear regression and clustering as well. Okay, so in this exercise, in this notebook, I'm going to show you how we can easily apply linear regression and clustering. Okay, now the data set that we are going to use is called Iris dataset, and this is like dataset introduced by a British scientist, okay? And they use it to solve kind of linear discriminant analysis. It has 5 attributes. So mainly it's about flowers, and we have information about flowers. So the aim of this dataset what? It's to tell the species of specific flower based on some attributes, sepal length and petal length. Okay, so I have the sepal and petal here length in centimeters. I have the sepal and the petal width in centimeters. So if I'm going to give you now some information about the length and the width of the sepal and the petal, you should be able to give me the correct species of this flower. And we have 3 different types of species, okay? And this is under the class. We have this setosa, we have this, and we have vigenica, okay? So we have 3 different, we have 3 different types of classes. So I want in linear regression or for instance, in classification, I can use those attributes to predict the correct class label. Okay, this is in classification. In clustering, I try to cluster those attributes. Okay, so I try to give my clustering algorithm those information about the flowers, and hopefully my clustering algorithm is going to group the flowers that they belong to the same species. Okay, so this is the data set. Any question about the data set? Any question about the data set? Is it clear? So again, in this data set, I have 5 attributes. I have information about the flowers. Okay, some information, length and width, and I have the class. Okay, and this class could be one of those following 3 values. Okay, and here you can see those 3 different types of flowers. Now, you can find more information about this data set in UCI. Okay, so what is UCI? UCI is a, let's say, public datasets repository that you can use to download and to experiment different machine learning problems. So if you are looking for a data set that you can use for exercises and training, you can go to UCI, or maybe Kaggle also is another good example. So let's start first exploring the data set. So first of all, I'm going to import my libraries. So here I need pandas to do some data pre-processing. Matplotlib, this is for data visualization, and NumPy for some arithmetic calculations. Now, to read a data set, I can rely on read CSV from pandas. Okay, so PD is the pandas.readcsv, and here you can provide a link to your dataset. Here I have it on my GitHub repository. Okay, so I'm going to load it from my repository. If you, by the way, I'm not sure if you have used Colab before, but here is a quick guide. So first of all, when you Google Colab on Google, you need to log in with your Gmail account. Once you are logged in, you should have something like this. Okay, so first of all, you need to be connected to the kernel. So you just need to click here, connect, and start to allocate some computational resources for you. This means you are going to be assigned a RAM and disk space to save your files. Now, if you have a file, external files, you can come from here from the folder. You can upload whatever you want, okay? And here you can mount this to your Google Drive as well if you have large files, okay? However, in our classes, I'm going to give you more time to explore the Colab. Let's continue now here with the data set. To run a code, guys, in this, you just need to click on this button here. So just need to run this. You see this green here. It's means that the cell is executed correctly. Now, with data exploration, I'm going to read my CSV file. I'm going to load the first 5 rows using the head method. Okay, so I'll click here. Again, you can see those are my attributes: simple length and simple width, pedal length and pedal width. Okay, and those are my species. Now, if I would like to know the number of, let's say, samples in my dataset, I can use the shape attribute. So as you can see here, what does this means? 156. What do you think? So what is this 150 and 6?
Rows and columns.
Exactly. So I have 150 rows, and I have how many columns? I have 6 columns, okay? And we call this as an index. As you can see here, we have a row index. This is like just to give you a sequence of the rows, okay? Now, if you'd like to know more about data set, for instance, the null values, the data type of each attributes you have, you can use the info method or function. So if we call iris.info, okay, you will get something like this. Show you how many attributes, those are your columns, okay? Those are the data types. This is, for instance, ID is integer, the other are floats, species is object, like string. Now, sometimes when we do data exploration, we should like get some statistical, let's say, analysis. Okay, about our attributes. For instance, it's sometimes useful to look at the minimum, maximum standard deviations of the attributes to see what is the data distribution. Okay, if you have skewness, if you don't have skewness, if you have outliers, stuff like that. Okay. So describe method give you access to those, let's say, basic summary statistics about the data set. Okay. Now, the first step in any data when you do machine learning is to verify that your data is clean. So you can do this by checking first the missing values. So if I key code that is null is going to tell you if you have null values or not. Then I'm going to sum them all together, find out how many null values for each attribute. As you can see here, my data set is clean. Okay, now I just need to plot to do some scatter plot for sepal length and sepal width. Okay, and I'm going to the colored. It's going to be species. Species mean that I have 3 species, so the library is going to give me 3 different colors automatically. I don't have to worry about the colors. Okay, and this is like seaborn plot. Okay, we call this from seaborn library. Okay, again, seaborn is really nice way for data exploration. You can use a lot of powerful functions, okay, to do nice plots like this. So it's just this is why this was like a quick data exploration. Now let's move to linear regression. So here I'm trying to remind you guys. I'm trying to remind you about this formula here. What is the formula of the linear regression? So here, this is my formula. It's y equals to b1 times x0 plus b0. Okay, so what is x? X is your input, and y is your target variables, and b1 and b0 are the coefficients. So here, I will try to predict the sepal length using the petal width. Okay, so what I'm trying to use now, I'm trying to use linear regression to predict what? The sepal length, taking into consideration the petal width. Okay, so my input variable in this case is only one attribute. Remember, we are talking about simple linear regression. So we talk about only 2 attributes. In my case, I want to predict the sepal length using the petal width. Okay, so this is my input petal. I want to use it to predict the length. Okay, and this is my output variable. I'm going in machine learning. It's good practice. We can see it all the time. We call the input. We refer to the input as X, the output as Y. Okay. Now, another important thing in machine learning is to split your data into training and testing. Okay, sets. This is very important when it comes to evaluate your model. Okay, we are going to use train test split from sklearn. Okay, to divide this data into training and testing set. I'm saying that I want 80% for training, 20% for testing. I'm going to add random state here because sometimes, machine learning in general, algorithms and function non-deterministic. Sometimes I need to repeat to get the same results all the time. So to make sure we add this random state variable, okay? Now here I'm trying to build my linear regression model. So in scikit-learn, it's very easy to create a model. First, you need to call the appropriate algorithm. So here I'm importing linear regression from the linear model, as you can see here. And then you need to fit it on your training set. Okay, so this is my linear regression model. I'm trying to fit it on fitting means start learning, start to discover patterns between input and output, start to find out the optimal value for those coefficients. Okay, in this formula, start to learn. Can you guess for me what is the value of B1? What is the value of B0? This is what the model tries to do now. Okay, now after fitting, I will try to print the intercept and the coefficient, and those are the values that I've got from my model. And the formula, the linear regression formula, is going to be like this. Do you remember what was the problem? I said I want to predict the length using the width. Okay, I want to predict the sepal length using the petal width. Okay, so as you can see here, the sepal length equals to 0.8 times petal width plus 4.77. Okay, so this is my x. If you remember the formula, this is the x. Okay, here, where was this is my x. B1 in this case is 0.8 and 4.7 is this B0. So B1 is the slope and this is the coefficient. Okay, guys. Now I can use now this formula to predict, okay, the sepal length. Now let's test it out. Okay. I will try now to apply this formula on the testing set. So first of all, I want to try this line here. Okay. I want to try this line here. As you can see, I have plotted the line. So I'm using plt.plot. So this is my x test. I'm using my testing set now. Okay. And this is my slope. And this is my other coefficient. Okay. So this is my line. If we let's say plotted the line, it's going to be something like this. This is the formula. Okay, and those points here, I have used this formula here to try to predict the values. And as you can see, my model is not that bad because most of the points, let's say, are close to the fitting line. And if we try to look at the those matrices, the mean square error, okay, or mean absolute error, you can see here I'm having some good values. The values are not too high, which means that my error is not that big. Okay, so which means that my regression model is doing fine. Now, let's move to clustering. In clustering here, what I will try to do, I'm going just to go back to these attributes. So what I will do in clustering, I will try to find out some homogeneous groups of my flowers using those attributes. So I'm going to I'm not going to consider the class, okay? Because I already know that what is the species, but I am using the clustering to try to group those clusters together, two flowers together, and hopefully I will get, it will be the same. It will be that all the points in one cluster will be assigned the same class, okay? So cluster one, hopefully I will get cluster one containing all the Setosa flowers, okay? And cluster number two is going hopefully to have all Virginica flowers and so on. Okay, so this is what I try to do in clustering. So what are the attributes that I need for my clustering? I need to get those four. I need to get the sepal length, sepal width, petal length, and petal weight. So those are the four attributes that I need for my clustering. And I have used iLook here in using pandas, okay, to get those four columns. Now, if you have seen this before, this means select all rows, okay? This like columns here means select all rows, and here I need the column 1, 2, 3, and 4. Okay, now using scikit-learn to import k-means. So I apply k-means. I've said I want 3 clusters. Okay, I want to the k-means plus plus. This is the kernel of the algorithm. I'm going to talk about different kernels when we go through the course. Maximum iteration and init. Those are some, let's say, hyperparameters of the algorithm. We can talk about this in more detail in the class. We can delete them as well here. So random state again, because I want to get same results again and again. We call the fit method again. on the data, and then I try to plot my clusters. Okay, so I have now, look what I'm trying to do here. I need to plot three, let's say subgroups, three clusters, right? So I have three scatter plots here. Okay, now first one, the first group is going to be the red one. And I'm trying here to filter the points, okay, from my input. You see, this is my input where the cluster number is 0. Okay, so I'm going to see what are the points that have been assigned cluster number 0. And those going to be the iris setosa. And similarly, I'm going to do for the other two species. And those are the assigned colors. Now, if we try to plot those, we are going to have something like this. So this is my clustering results. As you can see now, those the blue, the yellow things are the centroids of my clusters. Now, as you can see here, those are three, let's say, different or subgroups. As you can see here, my clustering is not like to be the best here because you see those 2 points here, those two clusters overlapping. Anyway, we should accept the fact that sometimes you are not going to develop the ideal models, okay? Maybe it needs tuning, maybe we need some kind of optimization. Okay, so I hope that I had shown you quickly some interesting introduction to machine learning. So in this session, we have seen three different types of machine learning. We have explored the linear regression, we talk about logistic regression, and finally, we have spot the light on k-means and how k-means works, okay? Now, I can see here some questions. Please, what represent intercept here? Alexander, can we also say, so let me go now through the questions. Okay, so Alexander is saying, can we also say its coordinates, X and Y? So for what you are referring to, Alexander, here? So if so 150 and 6, which 150? This one. No, it's not coordinate, it's the shape. Okay, it's the shape of the data sets. It's mean that if you have an Excel file, okay, let's go back to Excel. You have in Excel files different rows and different columns, right? So this refers to the number of rows, and this refers to the number of columns.
Okay, so what I'm asking is if you viewing this on graph, you're having y-axis and x-axis. So can we also give it that kind of description, coordinate?
Yeah, but when you want to plot them, we are going to use the real values, those 5.1, 3.5. Yes, exactly. So you can consider those values as X and Y, and those are going to be plotted on the two-dimensional spaces, like the way we did here. So here I'm just printing the sepal length and sepal width. So you can consider this is the X, exactly the X values, and this is the Y values coordinates, okay? So this is my X value, X axis, and this is my Y axis, okay? Okay, perfect. Now, what else do we have? Please, what represent intercept here? So here, if we move to this formula here, so we've said that this is the input X, right? And this is now the slope, and this is the intercept. So sometimes we call them these coefficients with the B1, but okay, so you can this the intercept, okay, B0. Now, what else do we have? Please, can you explain how you generate the straight line? Yes, so straight lines. So in order to draw a line, I need a formula, right? I need to find out the formula of my line. And well, I have applied linear regression, and this is my intercept, and this is my coefficient. Okay, So those are the values that I need to draw my line. So the formula at the end is going to be something like this. My sepal length is going to be equal to 0.8 pedal width plus 4.7. Okay, so how to draw that? Well, I can use plot function. So I can say the x is going to be the x value is going to be from my x test set, which means some points of the data set. You remember I have splitted my data set into training and testing sets. Where was that? Sorry. Here. You remember I have splitted my original data set into training and testing purposes. So I'm going to rely on some part of it, small portion of it. Okay. It's used for testing purposes. So the x values are going to be from here. My y value is what? It's going to be this, right? This is the formula, right? And the pedal width, what is the pedal width in this case? It is the x test, right? So different values here together. Please, this is not, this is very important to consider. When we talk about numbers has this, let's say, not sure if you have seen this before. So in numbers, we use some kind of smart computation. We call it vectorization. So we don't have to go through loops. Okay, and this is very important for speedy and efficient computational. So we don't use loops. So here, if I want to do it traditional way, okay, I'm going to say for I from 0 to the number of points that I have. First, calculate the first y equal to this line, and then move to the second point, and the third point, and the fourth point. So it's going to be loop function. But here in NumPy and those libraries, okay, we don't use that. We just can't do it with one line of code. Okay, so imagine this line could do the trick. So I have a for loop. Okay, this for loop is going to go through the whole points here. So give me x here and y plotted, x and y plotted, x and y plotted. Okay, but I'm doing this with just only one single line of code. I hope now it's clear. Any further questions? Any further questions? Okay, guys, so finally, I would like to thank you for your time. I know now we are beyond the time, like we have a late like 10 minutes, okay? But it was really fun to see all of you. I really enjoyed being with you today. And hopefully I'll see you when you decide to join us in the classes, okay? In the classes, we are going to do a lot of those interesting examples. Thank you all. Yes, it's the same applied to the scatter graph.
What if the points is not getting in the linear regression, like when we apply the linear regression, the scattered point doesn't came in between the lines, like on the lines.
Yes,
It
so
just
that's
connect
why.
only 2 or 3 points.
Yeah, so sometimes again, this is kind of some, let's say, errors that we have to expect or accept when we develop machine learning models. You are not going to, from the first time, you are not going to find the optimal, let's say, fitting line that could equally fit the whole points in your data set, okay? And also finding such a line is going to be, like, say, uh, uh, impossible in most of the cases, unless we are talking about very optimal case, okay? So we have to accept the fact that our models are not going to be accurate. But the nice thing about linear regression is trying to give you those estimates. It's really useful when you want to give those estimates predictions. So if we talk about stock price, well, the estimate is going to be, for instance, 1.5 USD, or maybe the estimate of a house price. Okay, the house price, 3 bedroom is going to be like 220K. Okay, so it's really useful to do those estimates. Again, we are talking here about some kind of estimates. So we should be, we accept a margin of error. Other applications, maybe they don't accept this kind of error margin, especially when we talk about health things. And regression is widely used in some sort of, let's say, health applications, like finding the PMIs and like finding other, let's say, relations between different chemicals in your bodies. So we need to make sure sometimes also that those models are accurate and try to optimize them. Okay.
Um, what if we use the multiple linear regression for the points which we want to be in the linear thing? Like
Yeah,
we can
exactly.
use
We
it.
can do that. Yes, we can do that. We can, for instance, try to predict again the house price, taking into consideration the number of rooms, taking into consideration the number of bathrooms, taking into consideration the floor area. So I have now 3 inputs to predict the house price. Okay, and I can rely on a multiple linear regression to do that. We are, in the class, we are going to see some examples about those. Any other questions, guys? Okay, then thank you all. Okay, it was really nice to be with you and hopefully to see you next in September. Okay, thank you.